So, great to see so many of you here. Thank you for coming. My name is Sander Mak, and I have a confession to make. And my confession is, I like building monoliths. Wow, who says that nowadays, right? Because we hear about microservices all the time. Every conference we attend, every meetup we go to, we hear about microservices, technologies, when to use them, how to use them. It almost seems like there's no other way than to do microservices. Now, if I talk about monoliths, people typically think of messy code bases, spaghetti code, things like that. And it doesn't have to be a way. And we'll look at that in this session as well. So, am I saying that microservices are bad? No, not at all. I just want us to be able to critically think about what's happening in our industry, which patterns we're applying, and why we're going for microservices in so many cases. Is it hype? Is it warranted? And what are the actual arguments when you decide between a microservices architecture or a different architecture? So that's what we're going to be looking at this evening. And I don't expect everybody to agree with me when I talk about how I think about microservices, and that's okay. What I want to achieve here is not that everybody leaves this room and says, okay, well, probably that's the way to think about it, but I want everybody to be able to apply this to their own situation, to analyze their own systems, and to think about, okay, do I really need a microservices approach in this case, or are there other alternatives that maybe provide some of the same benefits without some of the costs that microservices bring? And that's a conversation that you should be having within your teams, within your companies, and view this talk as a way to kickstart these conversations. So, a little bit about me. Like I said, I'm Sander, I'm from the Netherlands. I work with Luminous, which is a software technology company in the Netherlands. We do also have an office in the UK, by the way, but I don't work there, I work in the Netherlands. And the interesting thing about Luminous as a software technology company is that we do both consultancy, so shorter projects for different companies in the Netherlands, but we also develop our own products that we put out in the market. And an interesting thing happens when you start developing products. Because products, they're not just something that you do for a year. No, you have to maintain it for a long time, right? So you have to maintain it for 4, 10, 15 years. And that really affects the choices that you make in your software development practices, but also in your technology stack. And that's why we pretty early on in our life cycle of products found out that modularity as an architectural principle is really one of the key influences that enables us to be agile, to deliver products quickly, and also to be able to maintain them for a long time. And if you say modules and Java, and then at least up until Java 9, there was mainly just one big library that you could use, or framework, which is OSGI. So I do a lot of work with OSGI. Maybe you've heard of it. If you haven't, doesn't matter. But with Java 9, as you've probably heard, we also got a module system in the Java language. So that's really what piqued our interest into Java 9 and the module system there. So this is sort of why we got started into looking into a successor maybe to OSGI for our product development. Well, it got even that far that we got the opportunity to write a book for O'Reilly about this module system, which is this book. But this talk won't be about the module system in Java per se. We'll do that in the second half of this evening. What I want to focus on now is why these sort of module systems seem to be popping up in languages. And we'll see other examples besides the Java module system as well. But it's interesting to see that this is something that's happening in our industry. So besides writing this book and also doing some work for Pluralsight, I really like to talk at meetups and conferences and meet new people and talk about this. So if you have any ideas after this talk, please talk to me over pizzas. I think we're getting pizzas here, so that's good. And let's discuss and let's see how we can together move our practices forward. So this talk has a question for a title: modules or microservices? And I don't want to leave you all hanging till the end, so I'll give the answer right now. Modules or microservices? Yes. You're all engineers, right? So you probably thought that this was an exclusive or. No, that's not how I view things. So either doing microservices or doing modular development with a module system in a language is not mutually exclusive. And we'll see that later how that works. But see this more as a application of the same principles but using different techniques. And also, being able to combine these different techniques is something that can be very valuable. And of course, being a consultant, the real answer, of course, is it depends. It really depends on your system, on your goals, on what you really want to achieve. And we'll hit some of these questions and some of these arguments that you should be having within your teams and with yourself about when to approach a problem with microservices and when not to do it. So before we dive into modules and microservices, let's try and zoom out a little bit and talk about the concept of modularity itself. And to do that, we don't even have to think about software. So to illustrate what modularity really is all about, I took this picture of the ISS. Well, actually, I wish I took this picture. I actually only found it on the internet and put it in a slide. But anyway, this is, at least I believe, this is a marvel of engineering, right? This is a space station that's floating up there that has been built over decades by different teams in different countries with different capabilities, different goals and different aims. But in the end, they managed to get up in the sky a single, fully functional space station. So did this happen by chance or by doing waterfall or something like that? No, I don't think so. The key part here is that this space station also consists of modules. These little segments, they all have their own function. They all are either research labs or have other functions in the space station. So they're really like encapsulated. And we'll talk about encapsulation later. And the interesting thing here is that it was built all around the world. And it came together in space and it worked. And why did it work? Well, because they didn't just do something. They really thought very hard about these interconnects between modules and these interfacing parts. And that's why an American team, a Russian team, a Japanese team, with all their own goals and aims with these modules, were able to put together a single system that works, that's reliable, that's even sort of extensible, although it's now decommissioned, sort of, so, well. But, I mean, 25 years, that's pretty good for such a big system. So, I think this principle of having a modular approach, of being able to farm out work to different teams, to be able to work in parallel, to have different functionality in the end come together in one big system, is also the #1 software architecture principle that we should all strive for. So if we apply this to software, and then we're zooming in a little bit again, then we can talk about the 3 tenets of modularity. So I think we all have sort of a feeling of what a module in the space station was, but what does it mean to create modules in software? Well, the first big important topic here is encapsulation, or strong encapsulation. And encapsulation is all about hiding stuff. And this sounds a bit counterintuitive to us, right? Because why would we want to talk about hiding stuff? We're all about open source, we want to know everything about anything, that's who we are. But it turns out that doesn't scale. If you want to build really big systems, you can't know every detail. It's better even if you don't know all the details of what the parts of the system that you want to use. So if you have a technology that enables you to sort of encapsulate and guard a part of your system so other parts cannot reach it, that's really important to build a modular system. The other one is well-defined interfaces. And this is like the interconnects in the space station that we talked about. Because even though encapsulation is important, if you hide everything, well, you don't really have a system that works together. So what you really want is a module to also expose some sort of well-defined interface. And we're not talking about technology here yet. This could be anything. This could be a REST interface, this could be a Java interface, this could be a service specification. It doesn't really matter. As long as there's a difference between what you publicly put out there and that other modules and other parts of the system use versus what's encapsulated, that's what modularity is all about. The last one is interesting in the sense that if you are going to create a system that is modular, then you'll end up with lots of modules, which sounds logical, but all these modules have to come together again into a single working system. And these modules, well, they need each other, right? They don't work in isolation. And there it becomes interesting, let's say. because you somehow need to manage these dependencies between these modules. And the better you can manage these dependencies, the more stable, reliable, and maintainable your system becomes. Again, I'm not talking about tools yet, I'm not talking about technology yet. These are all software development principles that come out of modular thinking, out of modular architecture. So keep these principles, these 3 tenets in mind during the rest of the talk, because you'll see them coming back in actual concrete technologies in various ways. And you'll see that every modular technology that we'll talk about, including microservices, does something with these principles. I already talked a little bit about why we chose for modular technologies and module systems in Java to build our products. And in the end, it all boils down to being agile, being able to create products with modules that can be put together in different configurations, where you can easily swap out internals, because if you have a truly encapsulated part of your module, then you can change it without impact on the other modules, because, well, they don't know about what's encapsulated. So this really is helpful in making your system agile and maintainable. Now, we're going to talk about both microservices and modules in this talk. And we'll see that they're similar, but definitely not the same. They do appeal to the same principles that we talked about. But first, we're going to talk about microservices. And I don't think there's really a set definition for microservices. So let's come up with one now. In this talk, we'll talk about microservices as being independently deployable software units, independently running processes. And we're not talking about these little technical services. No, we're really talking about a system where you decompose into, let's say, business or domain services, where I talk about a domain in the domain-driven design sense of things. And we'll see some examples later. This service tries to do one thing and tries to do it well, sort of the Unix philosophy. And the crucial part here is that these microservices, they communicate with each other over a network. Again, not talking about technology, this could be anything. This could be REST over HTTP, this could be gRPC, this could be queues. Doesn't really matter. In the end, there's somewhere, computer here, computer there, or VM, or cloud instance, whatever, and they need to talk over a network. And that turns out to be a crucial element in microservice architectures. So, having said that, what do we see here? Anyone want to take a guess? It's sort of like a mirror image, but not really. Now, this is the microservices dev room at the FOSDEM conference. And you can see it's packed, right? People are really, really into microservices. Where are they? Because what I see is people looking in despair, right? It's really, they're even praying for a better solution. You see that? This is really it. People, come on. So, all kidding aside, I mean, yes, we've all heard the talks and we've probably experienced ourselves that microservices are hard to pull off. So that does mean that we need a very good reason to go down this route. And there are good reasons. But I don't think people really appreciate the discussion around this enough, because there are also some reasons that seem obvious, but really aren't reasons to do microservices, but are more reasons to do modular architectures and modular development. And there are more ways to do that than just microservices. So it's all about being able to think about when to use an approach and what the alternatives might be. So why do people typically choose microservices architectures? Well, one of these arguments that you often hear is that we have this big and complex application that we really can't evolve anymore. Well, the big monolith that I talked about in the beginning, it's really hard to manage this complexity and to keep teams working on it. Which sounds like a real problem that you need to solve, definitely. Other reasons might be around scaling, right? Where you have these independent services and you want to scale them maybe differently. Also, since they're independent, you can build sort of the resilience into your architecture, where you have these patterns like services with circuit breakers and bulkheading, etc. So these are some reasons why people typically choose microservices. But if you really think about the first reason, this management of the complexity of software development, it's really a cry for modularity in disguise. And yes, you do create a modular system if you put a network in between. You're actually forced to build a modular system that way. But it's kind of a crude tool, right? If that's the only reason to do it. So let's zoom in on this a little bit more and try to see what microservices bring to the table. So here's a really simple example from the educational perspective, where we have assignments service, learning materials service, we have student service. This is something that we sort of get a feeling, okay, these are nice business-oriented microservices, right? And when people talk about the alternative, they think about spaghetti code, where all these concepts are just thrown together and we have like this uncommented spaghetti code. And I believe this is a false dichotomy. This is not really how it works in the real world, right? I mean, there are spaghetti code bases, really. I've seen them. I've maybe created one or two. Sorry about that. But this is not really the only choice that we have. Because if we think about these spaghetti code bases, right? Then there's this curve that we have. So we start developing, and if you start with a monolith, you just create a Git repository, you start coding, right? And then you code more and more and more, and after a year or maybe 2 years, and now there are 3 or 4 teams working on it, things are getting hairy. And it becomes harder and harder to introduce new features, takes longer, it just becomes costlier. So you sort of hit a brick wall in terms of cost of developing these messy monoliths, which is one of the reasons why people flock to microservices. What you see there is that you get a more linear scaling, because you can just create a new service if you want to have a new team working on some new functionality. And you have another team, oh well, create another service, right? And this scales pretty nicely, and of course you need to integrate somehow, and that might get harder, so it does get a little bit costlier, but it's more linear than working on this messy monolith. But if you really look at this picture, this is of course one of the problems, right? If you start developing a monolith, like I said, it's pretty low cost. If you start developing a microservices architecture, well, you have some work cut out for you. You need to think about lots of things that you previously didn't have to think about. What things? Well, for example, things like service discovery. If you have all these independent services running everywhere, how do they find each other? Well, that's something that you need to solve. And of course, every problem has a solution. In this case, the problem has many solutions. You could use console etcd, something from the Netflix stack, but that's something that you need to learn, that you need to introduce, that you need to train people in. And not that it's a problem that cannot be solved, but it's part of this cost gap between a monolithic approach and a microservices approach. And there are more, right? And this might lead into something like a service mesh, which is a product that sort of tries to solve this problem, and then some more, like Istio and things, systems like that are becoming popular. But I've also seen some service messes. And that's really something and that can get to you quite easily if you're jumping into this and just trying some products and seeing if it's cool, if it works. That's really easy to get into. Another thing that you run into, of course, when you do distributed systems, when you do microservices, is that you run into all the fallacies of networking that we hopefully have heard about. I mean, the network is not fast. I mean, there will always be latency. It's not reliable. There will always be partitions and problems in the network. And of course, again, this is a problem that you can solve. But typically, it's not a problem that you really had before. And now you need to card in something like Hystrix and think about circuit breakers, bulk heading, things like that. You need to do some distributed tracing, monitoring, Zipkin, proxying between the services, maybe with something like Envoy. We're already at like 6 or 7 new technologies before we can roll out our microservices. What about deployment? Well, that's a solved problem, right? Just put it in a Docker container like everybody does nowadays. Well, yes, maybe, but then you got to run it somewhere, you got to orchestrate them using maybe Kubernetes or Mesos or another technology. Or maybe we should look at Amazon Firecracker that was just released at Amazon reInvent. I mean, there's lots and lots of choices here to make as well if you go down this route. And again, not that that's a bad thing, and if you need it, there are great solutions. But do you really want to take in all this complexity from the get-go if you're creating a system? That's a question that should at least get some consideration, in my opinion. So other things that come with microservices more than with monolithic systems, things like configuration management. Every service has an API, maybe even multiple versions, so you need to manage this somehow. And again, there are tools that you can learn and that you can start using. But this is part of this gap between the monolithic approach and the microservices approach. So all in all, and there's also security, by the way, which becomes quite different as well in a microservices architecture. Are you going to delegate security through all your services? Do you have some front end that handles it and has trusted subsystems? Again, much choices to make, which are solvable with new technology, new patterns, and so on. So some people call this architecture. It might also devolve into architecture. So really, this is a double-edged sword. And like I said, it's not that I don't like these technologies. In fact, I really like them, and it's cool to play with them. But that's not a reason to start using them if you don't need them. And the question is, what do the other alternatives of modular development offer us in that sense? Because, okay, this is really something that we can have a picture now. This cost gap, this is really something that you need to take into account, but we still have this brick wall as well for the messy monolith. So if we somehow can turn this monolithic development into something that's more structured, something that's more modular, then we might find a middle road. But wait, people say, this is a bit too pessimistic because we have vendors who help us with these upfront costs, right? We have OpenShift, we have Cloud Foundry, we have Service Fabric in Azure, we have the reactive platform from Lightbend. And true, there are some combinations of technologies that are pre-made for you that you can buy or use in open source. But that doesn't magically turn your team into a microservices team, right? Because it's not only about the technologies and the technology selection and learning about the technologies, it's also about the mindset of creating a distributed system. So yes, having these pre-made platforms really helps, and things are getting better and better there. That's very true. But at the same time, microservices will always be harder than monoliths. There's no point in arguing that. So what about the middle of the road? What if we want to build a monolithic application, but we don't want to end up in a mess? We want to have something that's modular. So let's look back at this microservices example that we had, where we had these independent services, all the domains that were covered in different domain services. The interesting thing is that this doesn't have to be like spaghetti code if you do a monolith. There's no reason why a single monolithic but modular application can't be modeled in the same way as this microservices landscape that you had. Only now we're going to use a module system to enforce these boundaries, to create these modules, to manage dependencies between modules, without having necessarily the network in between all these modules that we have. And the question is, does this give us something like this? And I believe it does. It does give us a middle of the road option where we, instead of starting with a clean sheet, messy monolith, there's a little bit more upfront cost because we need to learn about using a module system and using modular technologies, but it's not nearly as much as jumping to a microservices architecture. So people often ask me, okay, I've heard some of these modular principles and it really sounds like object-oriented programming to me. Like encapsulation, well, we can have private fields in a class. And the interfaces, well, we have interfaces in Java. Isn't this the same as modular development? And in a sense, yes, because these same principles at the class level also apply at a higher level, at the level of modules. It's only that if you think about only classes, then you're thinking too fine-grained. We want to think in something that's equivalent to the services that we saw in microservices. And a microservice is not a single class. So what module systems offer is something at the level in between classes and packages that we have at a low level in languages like Java, and between a whole system. So it's right in between there. So we can structure our system in different modules, and we can encapsulate inside of these modules, and we can have explicit dependencies between these modules, all managed by a module system. Now, what about module systems? Well, I already talked about Java, right? So there's a module system that was introduced in Java 9, and before that, you could already do modular development using the OSGI technology in Java. But that's not just the only game in town. Even JavaScript, for example, got modules in ES 2015. And this is something that you see recurring in different languages as well. They're even talking about a module system for C++ that might be targeted for the next revision, which is C++ 20. And also Go, for example, has recently got a module system that will be part of Go 1.13. So this is not something that's just happening in the Java space. This is something that's happening across different languages, across different ecosystems. And the thing that binds all these module systems together are these three principles that we talked about, these three tenets of modularity. So strong encapsulation, well-defined interfaces, and explicit dependencies. So let's talk a little bit about these module systems to get a feel of what they look like. So in Java 9, we got modules, and we'll talk a little bit more about this after the break. But just a quick overview. A module is something that gives metadata for jar files. This is a fairly intuitive way to think about this. And a jar file is a collection of packages, and some of these packages might be exported to the outside world with a exports keyword. So here we have a module that's called attendance. That's one of the modules of our educational system. But we also know that modules need other modules to do their work. So in this case, the attendance module has two require statements, and these require statements say, okay, this module needs code from the students module and the courses module to implement the attendance functionality. So if we map these three principles to the Java module system, what we see here is that we get strong encapsulation, in the sense that any package that is not exported from a module in Java is by default strongly encapsulated. So that means that no other module can use this code, can compile against this code, and can accidentally use implementation details. So other modules can only use what is exported, in this case in the API package. And this API package, it constitutes the well-defined interface of the module. So all types that are in attendance.api are what you promise to the outside world. This might be value types. This might be an interface for which you have an implementation in your encapsulated packages. So this is really something that separates whatever you promise to the outside world from your module, from what is encapsulated and what you should be able to change easily. Now, the last part, explicit dependencies, well, that maps to the require statements that we have here. So in the Java module system, if you have this module, it will know that it needs the other modules to do its work. And it will actually refuse to start the system if these modules are not there. And that's a big difference with how it was before in Java, because there we had jar files and a class path. And these jar files, well, they didn't really know about other jar files. You, as a developer, had to make sure that the class path was right. And I think we've all run into issues with class paths, at least I have. And it's actually a pretty brittle mechanism. So modules improve upon this by having explicit dependencies as well. Now, the interesting thing in Java is that they didn't just create this module system for us to use as developers. No, they also implemented the JDK, so Java itself, using modules. And what you see here is a subset of the modules that are in Java. And this used to be one big monolith. right? So Java itself used to be one big monolith with all the associated drawbacks. So it was hard to evolve. It was hard to see the impact of changes because anything could depend on anything. And now we have all these individual modules that all have explicit dependencies, and we can exactly see what's going on where. So what happens if you create a modular system in Java with these module descriptors is that there is a process that does module resolution. So in fact, if you start a module which has a module descriptor, as we saw before, then the module system in Java will verify that all the dependencies are there. And this is something that we usually delegated to our build tools before the module system. Because, well, yeah, the Mavens and the Gradles of the world really had to help us to get all the dependencies right. So this is really something that's now native to the platform, which is, in my opinion, a really, really great addition. We'll talk a little bit more about the Java module system after the break. For now, just to compare and contrast, let's look at JavaScript. Because there, we also got a module system, like I said, in ES 2015. And the interesting thing is that the same principles are at play that we saw in the Java module system. So here's the syntax for using modules in JavaScript. You can now export things, for example, functions. So in the top file, we export a function called sq for square. And this uses a secret function, which is defined in the same source file, but that one is not exported. So what we now can do in another JavaScript file is say, okay, we want to import sq from my module, and my module is then the top level file. And what we can do is we can call sq, but we cannot call secret. Again, these principles are at play here. So strong encapsulation, the secret function here, it's strongly encapsulated because you cannot reach it from outside the module. The well-defined interface is defined by everything that's exported from this JavaScript module. And if you import, well, that's a form of explicit dependencies. And again, this forms a graph of modules that can be verified, that can be used by tools, that can help you to understand your system. So, different language, same principles. If you're actually doing JavaScript development and using modules there, when talking about well-defined interfaces, I really like TypeScript as well. So if you are doing JavaScript development, really try to have a look at that as well, because it allows you to express types in JavaScript, and types, we all know as Java developers, are really helpful in describing interfaces and describing promises to other people and checking those promises using the TypeScript compiler in this case. So I've even heard they did something with CSS modules, but well, let's not go there because, well, CSS. So last one, C++. Like I said, this is not final yet, so this is something that's currently being spec'd out. But they're pretty far along, and here you can see that you have also an export keyword in C++. So this is the same example that we saw in the JavaScript. We export some function, in this case it's a C++ function, and we have some secret internal function that does the actual squaring. And then in another module, we don't do include files anymore. No, we can actually import something, and we can import standard I/O, but we can also import the my module that we defined above. So again, mapping the same principles, strong encapsulation, secret here is encapsulated, so we can change it freely without anybody complaining, because, well, they can't see it. They can only call through our well-defined interface, which is the function defined here that is exported. And because of the import statements, we have explicit dependencies. Again, something that tools can work with, that can help you in structure the system, that can help you in verify the system. So that's something that's coming, hopefully, in the new iteration of C++. So you could definitely say that modules are becoming widespread. And that begs the question, of course, how should we use them? And when should we use them? So again, modules, think of them as being between the level of objects and whole applications. And they help you in structuring and managing complexity. So the interesting thing is, of course, that we always made these sort of whiteboard designs of systems. Whether we were going to do microservices or monolithic development, doesn't really matter. This is how we think as developers, as architects. But before module systems in languages, this picture was really hard to translate into code because it really depends on the discipline of developers to not use impl packages, for example. You see that a lot. Or to be able to express dependencies. We used some external tooling like POMs and things like that. So now with module systems, we don't have to rely on the discipline of developers. No, we can actually have Java or JavaScript or C++ help us in developing modular applications because the compiler and the runtimes, they know about modules, they know about the boundaries that we want to draw about around specific pieces of functionality in the system using modules. They know whatever we want to strongly encapsulate. The tools now know to guard this, to not expose this to other modules. So that's really helpful to translate these whiteboard designs into actual code. So back to our question, modules or microservices. And like I said, it really depends on what you're trying to solve, which problem you're trying to tackle here. So I think we've seen that if you want to manage complexity, you don't necessarily have to put a network boundary in between your services. You can just as easily create a system where the boundaries that you drew up are modules. Java modules, JavaScript modules, C++ modules, doesn't really matter. But you can assign these to a team as well, and they can export something from this module, which is what they want to promise to other teams, what they want to promise to other parts of the system, and you can bring them together because you have, well, a description explicitly of the dependencies between these modules. But it still leaves the question of the other reasons for going with microservices, like scaling and resilience and things like that. So let's think a little bit more about that. So microservices do have advantages, right? If you compare it to a module system. Because with microservices, you can actually pick the best stack for each service, which sounds like a great idea and might be a real advantage in some cases, but it is also a risk because I've seen many organizations where they sort of adapted this mindset of just pick whatever is best for the service, and they now are really in dire need of Haskell developers. Okay, well, or even Smalltalk. I know a company in the Netherlands that does Smalltalk because it's, well, I don't know. But, I mean, yeah, it can be an advantage, it can also be a risk. But it's a difference between modules and microservices. Another thing to think about is deployment, right? If we're going to create a modular application, it's still a single unit of deployment. And whether that's acceptable or not really is, again, depends on the circumstances. So if you really want to have the ability to swap out a part of your system without bringing up or down other services, well, yes, then microservices are a pretty good way to do that. On the other hand, it's also really easy to get a sort of distributed monolith, right? Where people just naively took the services that were in a monolithic application, they extracted them, and now they have this very entangled web of services. And you can't really bring one service down without the other also going down because, well, there's a dependency there and it needs to call the other service. And maybe even a circular dependency if you're not, if you're unlucky. So again, yes, if you want independent deployment for your services, microservices definitely is the way to go. But it's all too easy to end up in this situation. So you really need to design for autonomy in that case. And that's not as easy as it sounds on paper. So related to this independent deployment, you can also talk about independent failure. If we have microservices and one service goes down, then, well, probably, hopefully, only that service is affected and not the rest of the system. But again, that depends on the assumption of having autonomous services. Because if we do have these dependencies that we had in the previous slide, well, then if one service goes down, it really cascades into the other services. And I've seen that a lot in practice too. So there people went out of their ways to create a microservices landscape. And in the end, what they had was a distributed monolith. And then you have the worst of both worlds. So really, Again, I'm not saying this is not a problem that cannot be solved, but again, it's something that will cost you in terms of design for autonomy, in terms of how you actually set up these services, and that's something that you need to factor in from the start when you do microservices. So, independent scaling. This is also related to independent deployment, of course. So what you can do in terms of microservices is say, okay, maybe my learning material service is really graphics intensive or whatever. So if I were to deploy this on Amazon, I would scale this with 4 big GPU instances. I don't know. And my student service, well, that's just a plain administrative service, so I just have 2 T2 mediums for redundancy. And assignments, well, nobody uses that, so we'll just have it chugging along on a small micro server. This is something that you can do in a microservice approach, and that's not possible in the monolithic deployment approach. So if this really is something that you need, then by all means, make different services, deploy them independently. But again, you might also just do this. And actually this is what we do with our modular applications. So we have a modular application which is composed of domain services, but these domain services, they live in modules rather than in microservices, so they come together in a single unit of deployment. But of course you can still scale this monolith, and you can just run it 3 times behind the load balancer. And no, you cannot scale the individual services in different ways over hardware, but a monolith doesn't mean that your system isn't scalable in general. So that's something that you need to keep in mind when comparing these approaches. So both are scalable, only if you do microservices, you can have independent scaling patterns for different services, which might be something that you need, but in a lot of systems that we build at least, it's not as clear-cut. So, looking from the other side, if you choose to do modular development rather than microservices, what are some of the advantages that you have? Well, not too surprising, if you have this single unit of deployment, it makes the management of your deployments and rolling out a system quite a bit easier. So, in this case, we have this system which is consisting of modules, but they're all bundled into this application that we can deploy somewhere. And again, this can be scaled, doesn't really matter, but this is really easy to manage. And we don't have the issue of the dependencies between services because, well, it's all there in the deployment unit. If you want to do 0 downtime, yeah, then you need to be smart about how you load balance before this and you swap out versions, etc. But that's essentially the same as you would do with a single microservice as well. The other interesting thing here is that you have very strong boundaries around these modules because we have strong encapsulation in most module systems, but they're easily refactorable. And if you have a microservices architecture and you have different teams working on these different services and you need to change something in an interface, that's a really big deal, right? And it's something that might affect REST interface documentation, that might affect lots of inter-team communication. Here we have a compiler that actually helps us and helps us in refactoring because we're still in a single code base. And yes, if we change something in the interface, well, that will probably have some effect, but we know exactly where the effect will be because we have these explicit dependencies that are in the module descriptors, that are in our source code, and that the compiler, the runtime, helps us with when we want to refactor. The interesting story there is the story about Uber, and this is a picture that I took from a talk that one of the lead architects gave. And then in 2014 they started from a single application and they started to do microservices. And what happened is that, well, things went pretty well up until around 2015, 2016, and there you see the steep increase of services. So in 2016 they had around 1,800 microservices in production, which, I mean, it's a ride-sharing service, right? That sounds like a lot to me. And he thought what happened there is that lots of times people wanted to use another service, but in a slightly different way. So the API maybe had to change a little bit, but to get the other team to change the API was really hard. because they had to talk to them, they had to persuade them that it was a good idea, etc., etc. So in the end, what mostly happened was that people just forked the microservices, they slightly changed it, and then they just deployed it. And that's how you get at 1800 microservices. So, I mean, that's another risk that you run in these cases. And of course, with discipline and governance, you can keep this in check if you have a microservices architecture. But, I mean, we all know pressure can be high, we need to deliver features, and it's all too easy to just fork something and change it, and then, well, we'll deal with it later, or not. Because we don't necessarily put a network boundary between our services, we have strongly typed in-process communication between services. And that also means that we effectively eliminate serialization or network latency for calls between services in our monolithic but modular application. Also, this gives us different possibilities, right? If you're a functional programmer, I mean, have you ever tried serializing a function over a network? It's pretty hard, right? And this is something that you can do if you're in the modular but monolithic approach. So if you do decide to go with microservices, I would strongly recommend looking at something that's more strongly typed than just a REST interface. Things like Avro, protocol buffers, anything that allows you to express your interface more concretely and more explicitly than just having some sort of JSON that maybe is well formed and maybe is not, is really something that you would want. But you get this for free if you create a modular Java application, for example. So another interesting point here is that, yes, if you do method calls between services in modules, those are synchronous and those are in process, like I said. You can still do things like asynchronous communication within a modular system, but it's a choice. It's not something that's forced upon you by the architecture. Because if you do microservices, if you have a distributed system, well, you're effectively, you don't have any other options than doing eventually consistency. So, talking about data and microservices and modular systems, it's still, even if you have a monolithic but modular application, it's still a good idea to partition your data and to say, okay, this module is responsible for this part of the data, this module is responsible for that part of the data. But that doesn't mean that it needs to be in a separate service or a separate database or a separate whatever. Again, if we think in terms of principles rather than technology, it's all about chopping up your domain into reasonable services. And I truly believe that in a modular system, you can also keep this partitioning both on the code side and the data side and have a system that's extensible, that's maintainable, and that's really a joy to work on. So the explicit dependencies in a module system are really helpful. Typically in a microservices architecture, there are not that many systems to record explicit dependencies between different services. So you're effectively looking at runtime traces, and if you're trying to discover what the dependencies are, well, chances are that you're best served if you look at network traffic or something like that. Not so in a module system, because there, for example in Java, we have these explicit module descriptors. We can create these module graphs, like I showed for the JDK. These are all generated from metadata. This is something that will give you and your team insight into the structure of the application. So let's wrap up for the first half. I ran across this tweet a little while ago. It says, okay, well, moving from a monolithic to a microservice architecture is a bit like going from classical to quantum mechanics. Reality, finally, we're free, right? It's a bit like, okay, well, Einstein, at the speed of light, everything changes, right? Our intuitions are wrong, but it's worth it. It's so cool. At the same time, 99% of the problems that we have in the real world are still solvable by classical mechanics, right? And I think it's a little bit the same with microservices and alternative architectures. People are so enthusiastic about all the technologies behind microservices, about Docker, Kubernetes, etc., that they're sort of losing sight of what we're actually doing here. We're creating software, we're modeling domains, we're creating something of value for users, right? And I don't think the users care about Kubernetes or whatever technology that we need to learn. So I think we all need to take a collective step back here. And I'm not saying we don't ever do microservices, but do them for the right reasons. In fact, don't solve problems that you don't have. Even better, don't introduce problems that you currently don't have for no good reason. Right? Looking back at all the tools for service discovery, etc., it's something if you introduce this into your organization, into your team. And sometimes, if you're Uber or Netflix or Google, well, there's a pretty good reason to do many of these things that we talked about. So we are typically here, at least in the systems that I build. And in that case, well, I think there's a real good reason to have a discussion around the approach that you take, and don't just jump on the hype train and say, okay, we're going to do microservices because they're cool, they're nice, they're hip, they're happening. No. In fact, Kubernetes seems to be an ancient Greek word meaning more containers than customers. I've heard from a very reliable source. So what do we want to do? We want to solve the problems that we have. At least I want to solve the problems that I have in the simplest possible way. And that means that at least I want to urge you to read up on the possibilities of modular development in your technology stack of choice. Whether that's Java, JavaScript, C++, doesn't really matter. As we've seen, this is something that's gaining prominence in language design and in language runtimes. And keep thinking about, okay, I'm designing a system. What does it mean in terms of encapsulation, interfaces I have between components, the dependencies that I have between components? This is valuable both in the microservices settings and in the setting where you do modular software development using, for example, Java or JavaScript. What's also a very nice approach is to design a system as if you were going to create microservices. Where you create this picture like I had, okay, we want to do something with students, assignments, learning material. Just create this whiteboard design. But don't build it as modules, don't build it as microservices from the start. Start with a modular application where you have the same boundaries, where you have the same interfaces between those domains in your application. And then once you have something and you start scaling it, you start building it out. If you see some bottleneck somewhere, if you have this service inside of a module that needs to be independently scaled, independently deployed, just pull it out of there and create a microservice or service out of it and integrate that with the rest of your application. And this way, at least in my experience, is a very nice way to actually get the real boundaries of your domain. Because at first you will get it wrong. And if you at first get it wrong in a microservices setup, it will be very costly to correct yourself. If you get it wrong in the modular application that we talked about, it's vastly easier to refactor and to change things around until you're actually sure about what's happening in your domain, how your domain actually decomposes. And you can always move to microservices and services later. Because the question is, what is a microservice? Does a service really need to be micro? Or can we somehow combine this modular approach that we have with a services approach? And well, yes, we can. I just talked about that. Where we pick out modules, a single module, maybe a subset of modules, and turn it into its own service. And a service, again, its internal structure can be structured using modules. So there's no either or choice here. It's just, do I need the network in between? Do I need the microservice approach for independent scaling, resilience? And if yes, well, then just pick up your application, yank out whatever you think needs to be scaled independently, deployed independently, and do it like that. So don't worry, you can still do all the buzzwords, even if you're not doing microservices. So reactive, NoSQL, cloud, DevOps, DDD. People are trying to sell this as a package deal with microservices, but it's completely orthogonal, right? And this is something that you should keep in mind as well. So it's perfectly possible to create a modular Java application that is fully built upon reactive principles, or that uses NoSQL, or that's deployed in the cloud, or etc., etc. So if there's one thing that you should take away from this talk, in my opinion, is think about the alternatives that you have. is not just the messy monolith and microservices all the way. There's also a level in between where you pick a modular technology to create your application, maybe tease out a few services, but you don't have to take this upfront cost of going microservices all the way from the very, very start. And with that, I'd like to thank you all for being here for the first half. If you're interested in this stuff, and if you're a Java developer, I highly recommend, of course, looking up javamodularity.com, where you can find information about the book.